Hello everybody, it's Mr. Edwards here. I'm Head of Physics at St Peter's School and this is a short presentation about what to expect if you study A-level physics and why it's good to study it and whether it's for you. On the screen you can see there's a little graphic there, a word cloud, obviously lots of words to do with physics, and you can see that it's a subject that encompasses a whole load of disciplines that overlap with lots of other subjects that you might be doing, and indeed are very, very useful for future careers. Why would people study physics? Well, in terms of helping you for your future, it's always listed as a very important subject that universities are looking at. So, for example, the Russell Group universities that are traditionally regarded as the high-level universities have listed physics, together with many other subjects, as a facilitating subject. So what that means is that you should have some of your A-levels as facilitating subjects, not all of them, but quite a few courses do specify physics as an A-level that you need to do, as well as obviously doing physics. Things like architecture require physics too. So it's a very useful A-level to have. And even if a university doesn't specify physics, it's always very highly regarded as something that if you manage to do it. Also with careers, employers, if you've done a physics A-level or a physics degree, you'll look very good on paper. There's a huge range of skills that physicists have that are very attractive to employers. And yes, it's widely regarded as a challenging A-level, and it is. Okay, so a big message here is only do physics if you like working hard and you like being challenged. It really rewards people who persevere with it. You don't have to be super bright, but you do have to work hard and be prepared to stretch yourself. And because of that, it's very highly regarded if you have a physics A-level. The exam board that we do is OCR Physics A. So OCR do two physics courses, A and B. The Physics B is what they call a contextual course. So it's basically they look at a context, like a car or something, and they bring in lots of physics to do with that context. Whereas Physics A is a conceptual course, so it just takes you through traditionally the things you need to understand. So you get a big overview of the physics at the end of the course. You can see there are lots of topics listed here, and the graphics on these screens are taken from the fact sheet that OCR have produced. I've given you a link at the top of the screen, so if you want to find out more information, indeed look at that, and indeed look at the OCR Physics website, because it gives you an awful lot of information. The first four bullet points here are taught alongside the topic. So we don't sort of do bullet point 1 followed by bullet point 2. We treat those as an ongoing study. So the first thing we look at is motion. And the massive difference between these topics and GCSE is the mathematical content. So if you like maths, it suddenly becomes very satisfying, and you can begin to see the power of the theory, which you don't necessarily see at GCSE. So things start making sense a lot more. You don't just have to learn it and accept things. You really begin to see how this all fits together very nicely. In the lower 6th year, we go all the way through to thermal physics on the right-hand column. So you can see that we do a bit of quantum physics, which is good fun. So that's totally different to anything that you've done before. Your whole world will fall apart for a little bit because it's very crazy, but it's very interesting as well because it's so different to what you're used to. The upper 6th is a combination of quite advanced maths. So the first two, the circular motion and oscillations, quite advanced maths there. And the rest of it really is using physics you've already learnt in the lower 6th in different contexts like astrophysics, medical imaging, nuclear and particle physics and things like that. So the last few months of your learning basically puts together everything you've learnt before, and you can see physics as it is a very holistic subject, and very powerful, these skills that you've been learning to problem solving, all sorts of things. Now that is why we're doing OCR Physics A actually. If you look at some of the topics in the upper sixth, like astrophysics and medical physics and particle physics, in the other exam boards, they're usually option choices, so you can only do astrophysics but not particle physics, for example. Whereas what OCR have done is got the best bits of all of the options, and everybody studies them, and we believe that's a much better way of doing it. So there's quite a bit of stuff that's incorporating all the other skills you've done. Notice at the bottom, it's not a lot about knowledge, it's much more about problem solving and practical skills. So that's in the exam as well. So again, that's different from GCSE, where there's lots of learning at GCSE. At A level, yes, of course there is learning, but you're given a big data booklet, for example, with all of the formulae in, bar about 3. So it's more of a, can you apply this on the spot? So problem solving, that's what they're really assessing. And the assessment at the end of the upper sixth is in 3 examinations of 6 hours in total. And you can see there that 2 of them are 2¼ hours, and the paper 3 is 1 hour and 30 minutes. There's a whole range of questions. So there's multiple choice questions in the first 2 papers, and then short answer, which you're used to at your GCSE, and extended response. They're usually out of 6 marks. Everybody's very scared of doing them, but we find that our students do very well with those once they've had a bit of exam practice. So you don't get any sort of 25-marker essay questions. They're 6 marks, and they're very easy really once you've got your head around it. The first paper is on half of the specification, the second paper is on the other half of the specification, and the paper 3 is a synoptic paper based on the whole specification. But the style of the questions in paper 3 are very different than the other 2, and it's a very challenging paper, that one. The practical endorsement, so this is the same with the other sciences. It's a separate qualification that you get. So you'll get a certificate with whatever grades you'll end up with in your physics as part of your A-level results, but you'll also get a separate certificate that says whether you've passed or failed your practical endorsement, and universities quite often specify that you have to pass the practical endorsement. This is different than biology and chemistry, who do the AQA specification, because with the AQA, there are 12 fixed practicals that everybody has to do. With the physics, that's not the same. So we have to do at least 12 practicals, but we can design the practicals as long as they cover the key skills that they need to cover. So it's much more flexible, and so we can actually do things that fit us and our equipment much more nicely. You're not, there's no coursework other than you've got to carry out these practicals, and then we've got to see you, for example, being able to measure the diameter of a wire using a micrometer. And as long as you can do that, you get a tick in a box, and then we've got to make sure we've ticked all the boxes by the end of the upper sixth. If you haven't ticked the boxes, then we will get you in at a lunchtime and train you again, and basically we'll just keep on going till you pass it, and we're absolutely encouraged to do that. So it's something that everybody will pass. It just depends how painful it is for you, how many times you have to relook at things. So that's the practical endorsement. The actual practical work, there's no coursework, but in the examination papers 30% of the marks are based on practicals. So that's how they do it. So you're sitting doing your normal A-level paper, but there'll be some questions about practical work on there. So it's things like analysing results or evaluating whether the experiment was a good experiment, etc. Now, finally, I need to talk to you about maths A-level, because there's a lot of maths in your physics. So as I said, 30% of the marks in the written papers are based on practical work. 40% of the marks, they could be the same mark, have to be mathematical. Okay, and that's quite hard maths as well. So you can see that a big chunk of your A-level grade will be based on how successful you've been on doing maths. So we absolutely recommend that you do maths A-level. If you want to do physics A-level, you do maths A-level too. We don't make you do that, some schools do, but we traditionally find that if you don't do maths A-level, you're going to struggle with your physics, okay, unless you're really good at maths. So you might have done maths A-level when you were 6, so therefore you don't have to do it now. Okay, they're the sort of people, I'm joking a little bit, but they're the sort of people who could cope with physics A-level without doing maths. Okay, so you do need to be strong at maths if you don't do maths A-level, but you've got to be capable of doing maths A-level, obviously if you are doing maths A-level, and so therefore that will obviously help your physics. There's a big overlap. So quite a lot of the mechanics at the beginning of the lower 6th course in physics, you also do in maths. So if you do the two subjects, they really complement each other, and your brain is training, being able to solve problems. So it's a huge recommendation from us that you do maths A-level if you want to do physics A-level. So hopefully that gives you a quick overview of what we do. Do look up OCR Physics A on their website, and it'll talk you through in a bit more detail. And obviously, please get in touch with me if you have any further questions. Okay, thank you very much.